this video, we'll be looking at a potential energy diagram for an endothermic reaction. Now, same thing as before. We have time on the x-axis and potential energy on the y. Now, this graph shape, once again, shows us how the energy of the reaction changes as time goes by. So, this would be the energy of the reactants and the energy of the products. So it looks like the energy of the reactants is a small amount, and the energy of the products is a large amount. So if we start with a little bit, and the reactants, as they turn into products, gain energy, that means energy is flowing in. That means we're looking at an endothermic reaction. Now, if that line represents the energy of the reactants, this is how much energy has to be supplied in order to get the reaction to go. Do you remember what that's called? The minimum amount of energy that has to be supplied in order for a reaction to go? Well, that's the energy of activation. Now, what does this amount of energy represent? Well, you know that this is the energy of the reactants, and this is the energy of the products. So this is the change in energy for the reaction, or the change in heat, or specifically the change in enthalpy. Now, do you remember the formula for change in enthalpy? Yeah, it's energy of the products minus energy of the reactants. So energy of the products minus energy of the reactants. So a big number minus a small number. So that should give us a positive value. Anytime you have a positive value, that tells us that the reaction is endothermic. The reaction would feel cool because energy is flowing from the surroundings into the reaction. So this is what a potential energy diagram looks like for an endothermic reaction. Be sure to familiarize yourself with all the components of this graph and be able to compare it and contrast it with an exothermic reaction.